So it looks like we're going to be doing the video now on the Reassessment Study Guide Part 1. So we're going all the way back to the beginning where we did sketching angles in standard position. Now, a reminder what standard position is. You have your y-axis here, your x-axis here. Standard position is you always have your initial side being the positive x-axis, initial. And then your terminal side is going to be wherever your angle ends. So for this case, if we're looking at 245 degrees, what we're going to do, we have our y-axis, we have our x-axis. Now, our initial side is the positive x-axis. And to show how far we go, we're going to always start at the positive x-axis. Now 745 degrees, I know it's going to be more than one rotation because a full rotation would be 360 degrees. Now if I go around one more time, that should be 720. So that means I just need to go 25 degrees more. I don't need to show the 25 degrees. I'm just going to write here that this is 745 degrees total. So that is how I would show the as a final answer. You don't need that 360, but to show your final answer, 745 degrees would be shown like that. Now here, that was going in the positive direction. If we're going in the negative direction, we're still, the initial side doesn't change. We're always starting at that positive x-axis, but now rather than going up, we're going to be going down in the negative direction. So I'm going to go negative 125 degrees, and that should be about right there. And I'm going to draw my terminal side, and that should be 125 degrees. Now, how do I know where degrees are and everything like that? You can go back to your unit circle and just know that a full circle is 360 degrees. If I was looking at this right here as all my degrees, I know here is 0 degrees, 90, 180, 270, and then full circle 360. If we're going in the negative direction like we did below, this would be 0, but then I'd go negative 90, negative 180, negative 270, and negative 360. So let's go to now this one over here, 230. Again, I want to draw my y-axis, my x-axis. I'm going to have that initial side there, and we go 230 degrees. Now that's not all the way to 70, but it's roughly close to it. So that should be 230 degrees. And last but not least, I'm going to give you a radian one, just one that we've been working with, pi over 4. We know that to be 45 degrees. So I'm going to have my initial side here, and I'm going to call this pi over 4. And that's how we're going back in and drawing angles in standard position. After that, we looked at determining, okay, let's find some coterminal angles. Remember, coterminal means two angles that share the same terminal side. So if we're looking at negative 528 degrees, we're looking for a positive angle that's less than 360 degrees and greater than 0 degrees that shares the same terminal side with negative 528. Now, you could do this graphically and just draw it how we did in the same angles, but I'm going to do this algebraically. Remember that a full rotation, a full circle is 360 degrees. So I'm going to take 528 degrees and I'm going to do a full rotation in the positive direction, which would be 360 degrees. When I do that, I'm going to be left with negative 168 degrees. Now, is that greater than 0 and less than 360? It is not. So we need to do another full rotation. When we do that full rotation, I'm going to see that I'm going to be left with 192 degrees. Now, it's 192 degrees less than 360 and greater than 0. In fact, it is. So we are good there. So let's look at this next one. We're looking at the positive angle that's less than 2 pi and greater than 0 radians. And it needs to be coterminal of 15 pi over 6. This one's a little bit harder, but same concept. Earlier we talked about our rotation, how this was 0, 90, 180, and 270. and 360. Now in radians, what it is we've been working a lot with the unit circle now, but this is 0, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. And we kind of got this, we did a little proof over in the very beginning of the year, but we don't have to go back into that. So 360 degrees is a full rotation, 2 pi is a full rotation. Now if I'm at 15 pi over 6, I need to get smaller than that, because if I'm looking at this 6 here in 2 pi, if I looked at 2 pi in terms of having a 6, I need to have that common denominator. So if I write 2 pi and try to get that denominator 6, I'm going to have it 6 on the bottom. 2 times 6 is 12. So then in this case, a full rotation would be 12 pi over 6. So initially we're taking away a full rotation, which is 2 pi. We just showed that 2 pi is equivalent to 12 pi over 6. So we're going to subtract 12 pi over 6 from 15 pi over 6, and that should give us 3 pi over 6. Now, it does look like 3 pi over 6 is greater than 0 radians and less than 2 pi, but what we can do with this is we can reduce it. And when we reduce 3 and 6 both share a number, that number is 3. So that can reduce to pi over 2. And that would be our final answer in terms of coterminal angles. Now, on top of things that we've done in the past, we're going to go back to converting angles to degrees. Now, if we're going from the two formulas that we memorized, if you're going to degrees to radians, you're going to be multiplying by pi over 180. And if you're going from radians to degrees, you're going to be multiplying by 180 over pi. So if we're coming over here, convert to radians, writing your terms of in pi, that means that we're just going to have a pi variable there. So we're going to have 70 degrees. We're going to multiply that by, using our formula here, degrees into radians. We're going to multiply by pi over 180. That would give us 70 pi over 180. Now, we need to reduce this into the smallest form possible. When we reduce this, we'll get 7 pi over 18. Now, how did I get 7 pi over 18? I noticed that 10 goes into 70 and it goes into 180. So I can divide 70 by 10 or 80 by 10. Now, if I go to my calculator, because sometimes we'll be able to use a calculator on parts of the section of the test, you can use the calculator to find the most reduced fraction. We just need to remind ourselves that we got to put in the pi. So we found that the 70 over 180, if I'm going to look at 70 over 180, that gave me this decimal. That's not a fraction. That's not 7/18. If I want to see what the most reduced form is, I'm going to go find my answer, turn that into a fraction, and right there, boom, 7/18. But here's the thing. The answer is not 7 over 18. We got to include that pi. So whenever you're using your calculator, you can find the most reduced fraction. Just a reminder, just to remember to put that pi into the numerator. So now we're here converting to degrees. We're going to have 5 pi over 9. If we're converting it to degrees, we're using this radians to degrees. We're going to multiply by 180 over pi then. So we have 5 pi times 180 over pi, or 5 pi over 9 times 180 over pi. The pi's will cancel out. So we'll have 5 times 180, which is 900. And we're going to divide that by 9. Coincidentally, 9 goes into 900, so that should simplify to 100 degrees. Now the last one is where we will need our calculator for. So we're going to go 320 degrees, convert that into radians. We're going to have 320 times pi over 180, which would leave us 320 pi over 180. Now, I'm going to go to my calculator. I'm going to type in 320. I've got pi, there's the pi, oh yeah, pi is second there. I'm going to divide that by 180. Our final answer then is 5.59. So you can leave it as 5.59 9. And that is your final answer. And I'm going to just draw some boxes, make sure that you know what the final answer is for there. Now the last one for this part of the video, I've broken up them into 3 parts so that we can kind of view it small chunks at a time. We're going to look at the Pythagorean identities. Now the Pythagorean identities will be given to you on the test. You don't have to memorize them, so you're all good. We have sine squared x plus cosine squared x is equal to 1. 1 plus cotangent squared x is equal to cosecant squared x, and tangent squared x plus 1 is equal to secant squared x. Essentially, when you're using Pythagorean identities, you're going to be given an equation very similar to this one. And if you're given an equation similar to this, you just need to figure out, okay, how can I use what I know here? Now, if I'm looking at secant squared x minus tangent squared x, the only one that includes both of those is this one here. So would it be smarter for me to plug in secant squared minus 1 to tangent squared x? Or, oh wait, there's a tangent here. I'm going to plug in this tangent squared x plus 1 into this secant squared x. So that would be tangent squared x plus 1 minus tangent squared x. Well, why did I do that? Well, what do we notice here? I'm gonna move some stuff around because addition is commutative. I'm gonna move this to where else you can see it a little bit better on why I did what I just did. What would happen right here if we have tangent squared x minus tangent squared x? They cancel, which leaves us the answer to be 1. And we're going to have a lot of different types of things, so if you need more practice of that, you can look back on old homework or anything like that. If we're looking at this problem here, you can kind of do the same thing, but here's the thing. These identities, these things, only work if these are the same. If you see a problem where they're not the same, this is the way you'll need to approach it. You'll need to take the cotangent of pi over 6, and then you just square what that is. And then you're going to add that to the secant of 3 pi and square that. Now the reason we can do that here but not here is because what's here? An x. We don't have a value for these, so we couldn't just say, oh, we'll just find the value and do that. Now if you looked at your unit circle, you would find out that the cotangent of pi over 6 would be the square root of 3. So you would square that value. And if you looked for the secant of 3 pi is coterminal with pi. You're going to find that that would be negative 1 squared. When you square both of these, you get the 3 square root of 3 squared is 3. You can add that to negative 1 squared, which negative 1 times negative 1 is a positive 1. That would give you a final answer of 4. And that will conclude our first video and our first part of part 1 retest.